Measure airflow precisely using the HVAC temperature rise formula to convert supply-return temperature difference into cubic feet per minute and verify system performance fast. For an accurate calculation, measure supply and return temperatures with a calibrated digital thermometer at least 5 minutes after the system has stabilized. Record the temperature rise to the nearest tenth of a degree Fahrenheit. Use the room-specific sensible heat formula CFM equals 335 times B2 per hour divided by the measured delta T when you know the heating output, or when using electric strip heat, use CFM equals heating kilowatts times 3,400 divided by 120 times delta T with proper unit conversions. Always double-check units before plugging numbers. If you do not have direct B2 per hour from the furnace, measure electrical current and voltage for electric heat, or read the rated input on the nameplate and correct for blower off cycle time. Document whether ratings are steady state or nameplate values. When the air handler lacks separate taps for heating and cooling, run the system in the mode that matches the tested coil and note that dual speed or dual tap assumptions do not apply. Use the available tap and annotate the measurement as single tap configuration so later comparisons are valid. Average multiple readings across the duct face using a straight edge grid, or at least 5 evenly spaced points for round ducts and 9 for rectangular ducts to reduce sampling error. Always subtract the static pressure offset if you use an anemometer that requires it. Correct for return air mixing by measuring actual return temperature nearest the blower inlet, not a grill where stratification occurs, and if necessary, temporarily seal nearby doors to stabilize return conditions. For long runs, account for heat gain or loss in the duct by measuring temperature at the coil and at the supply register and note duct insulation R value. If significant, place probes at both ends and use the coil side delta T for CFM calculation. Finally, record ambient conditions, equipment serial numbers, fan speed or drive frequency, and the exact method used so a later technician can reproduce or audit the measurement without guessing. One of the top 3 common mistakes is relying on single-point temperature readings for airflow CFM calculation, which creates large errors in delta T and leads to wrong system balancing. Fix this by averaging multiple points across the duct and waiting for thermal stabilization before recording values. One of the next frequent errors is using nameplate heating output without correcting for actual operating conditions or cycling, producing erroneous cubic feet per minute numbers. Fix this by measuring electrical input or fuel flow where possible and adjusting for on-off duty cycle, or measure coil B2 directly with calibrated instruments. One of the third common issues is assuming dual speed or separate taps exist when the air handler is single tap, causing inconsistent trend data and misapplied performance targets. Fix this by documenting the single tap configuration, using the available tap consistently, and flagging the unit for future upgrade or notation in the service record so reference measurements remain comparable. BigHomeProjects.com lists trusted local HVAC contractors and lets homeowners filter by verified skills and past project photos to match the specific airflow and temperature rise expertise needed. The directory also helps contractors gain local leads by showcasing their certifications, detailed service descriptions, and customer reviews, so they get work from homeowners seeking precise HVAC testing and balancing.